Okay, last time in the chapter of light, we discussed the concept of the concave lens and the convex lens, and we also discussed the difference between the concave and convex lens, right? And in convex lens, we discussed that all light rays will pass through a single point, which is known as the principal focus, and the distance from the center of the lens to that principal focus is known as the focal length, and the line which is passing through the center and through the principal focus is known as principal axis. So these are all key terms that we discussed in the last class. And today we have to start with the concept of image formation. And if you remember, I told you that we only have to discuss the image formation in the sense of only convex lens.
Yes.
So basically, convex lens is converging. So that's why we are only talking about the convex lens. And I also told you that in your exam, you will find a lens in a straight line form because it was written in the question that we are using convex lens or a concave lens. So it is not compulsory to make every time that shape because that shape you already know the concept, you already know the difference. So that's why it is not important to consider that shape again and again. So there are different situations, there are different scenario that we have to discuss in this situation. Let's suppose if we first talk about the first case. So in the first case, let's suppose if we place object beyond 2f. So the first case is when object is placed beyond 2f. So let's suppose if we consider, so this is our principal axis, and in center we are having our lens. So basically this is the lens, right? Now we have to mark principal focus on both sides, and you know that principal focus will be at the same distance. Like if we mark 1, 2, 3, 4. So let's suppose if this is f, so this will also f, and 2f means to double the focal length, the distance that is doubled. So 1, 2, 3, 4. This will be 2f, 1, 2, 3, 4. And in your exam, if they ask you to draw the diagram, so there is a graph type paper or graph type part given in your exam also. So that is very easy to identify the actual distance and equal distance on both sides, right? Just like in the same diagram we are talking about. And let's suppose if we place our object beyond 2f, and let's suppose this is our object, and from the object we have to consider the ray of the light passing from the object. Let's suppose first we consider the horizontal one. So one is the possibility that light might pass parallel to the principal axis. So you know that it will always pass through the principal focus, right? Okay. And if light passes from the
Yes.
center, so it will always move through the center, right?
Sir.
Like this. Okay. So now you can see that line is intersecting between F and 2F. So your image will be formed at this point. Okay. So this will be your image. So when line is going to be intersect, so that will be the image formed from the convex lens, right? So they also ask in
Right.
exam to write the characteristics of the image or the specification of the image that is going to be formed at that point. So let's suppose if we want to write some points related to the image. So the first point that we observe from this picture or from this whole diagram, that your image is formed between F and 2F, right? So your image will form between F and 2F. And the second thing is you can see that your arrow is in inverted form. So your image will be inverted, right?
Yes, sir.
And another point, if you remember, we also discussed the concept of uh, the real image and the virtual image. So this is real image because it is going to be formed on the other side. So it is real image. And if we talk about the size of the image, the size of the image is small or as compared to the object, right? Small in size. Okay. So these are the points related to the first case when object is placed beyond 2F, right?
Yes.
And if we consider the second situation and you have to memorize all these cases, I will also give you the short form that how to memorize this case. If we consider the second case, so in the second situation, when we consider that now object is placed at, right? So if we consider the new condition when object is placed at 2F, so let's see how your image is going to be formed in that scenario. Let's suppose if we again consider the lens and the principal axis. So this is your principal axis. Again, we just need to take the lens. So this is your lens again. And again, we have to mark F and 2F on the both sides. So 1, 2, 3, 4, 5, 6, 7, 8. 2F, 1, 2, 3, 4. This will be F, 1, 2, 3, 4. F, 1, 2, 3, 4, 2F, right? So now these are the situation for the scenario. And again, we have to place the object. Again, we place the object at 2F. And this is the object place over here. Again, we consider the two ray diagram which is passing parallel to the axis of principal. and second one is passing from the center. So again, if we consider two rays, one is parallel to the axis and second one is going to be passed from the center. This is the path of the first ray, right? Passing from the principal focus always. And if we consider the second one, so you know that second one will pass from the center and it will move in a straight line. So you can see that line is again intersecting and you will get the image over here. This is the your image. Okay, basically you can identify the size with the help of the number of boxes. You can see that your object is about 3 boxes high from the principal axis and you are getting same height in your image, that is 3 boxes. So it means that your image is of same size. Okay.
Okay.
Now again we have to write some specification for this image. So the again first one is we have to write the position. So position as object is placed at 2f and your image will form at 2f also on the other side. And the second point is image is again inverted. Third point is image is real. And the next point is same size. Okay, clear?
Yes.
So now how to memorize these specification, because these are only two cases, we have to discuss two more. So basically you can observe from the diagram that when your object is away from the lens, so your image is close to the lens, right? Like in first case, image is between f and 2f. And when you shift your object close to the lens, like in second case at 2f, so your image will shift away from the lens, right? So basically, you have to move the image with the equal amount that object is moving close to the lens. When object is moving close to the lens, so your image will shift with the same amount away from the lens. And when your object is moving away from the lens, so you have to shift your image with the same amount close to the lens, right? So both are moving like in opposite way. Like if your object is placed or object is moving towards or close to the lens, so your image will form or your image will move away from the lens, right? Okay. And now if we consider the third case, so then you will be able to understand more clearly that how your image is going to be shift away from the lens. So let's suppose if we consider the third case, so in third case your object is now placed between f and 2f, right? So again, we have to take that principles and that length. So let's suppose this is our principle and we have to mark the length over it. This is the lens, and we have to mark f and 2f. So 1, 2, 3, 4, 1, 2, 3, 4. And it is not compulsory to always mark f at 4 boxes, because in question they gave you the reference that at which point your focal length or your principal focus is. So basically I am marking at equal distance, so that you will also get the idea that you also need to mark both points at same distance on both sides of the lenses, right? So 1, 2,
Right.
3, 4, 1, 2, 3, 4. So let's suppose if we place object in the middle between f and 2f, you may place f anywhere, but we are just placing straight in the middle between f and 2f. So this is the position of object this time. And now we have to identify the ray diagram for this object. So one image will, or one ray will always move to the axis, and second one will move from the center. So first one will always pass through the focus. Okay. And the next one will pass from the center. Okay. And now you can see that your line is intersecting at a point. This is your image, right? In third case. So again, a very simple concept. You are getting your image in inverted form with real nature. So the first point is that you need to write the position. Is the position of the image. Image is formed beyond 2f, right?
Yeah, it's like, yeah. I was between.
The green line, it is
Oh,
beyond, right?
oh, okay, I get it.
Yes, your object is blue color, that is given in the third part, that is between f and 2f, right? And the nature of the image is real. And the third one is inverted. And what will be the size of the image? Can you identify the size from the diagram? Is it greater, equal, less?
Wouldn't it be greater?
Greater, because you can easily count the boxes, because in your boxes that is given in your object is equals to 3 boxes, right? It is 3 box high from the principal axis. And if you take the height of the image, so the height of the image given on the other side is like 1, 2, 3, 4, 5 boxes. So it is magnified as compared to the given size of the object, right?
Oh, yeah.
So you can easily identify the size. That's why I use the graph paper, because in your questions, in your exam paper, they will also give you the same concept. So that will be easy for you to identify the concept, right? So the next point is magnified image. Clear?
Yes.
Okay, now we discuss all the concept related to the real image, right? But what if your object or your lens will make, or your image that is going to be formed from the convex lens will be virtual? Because in the notes we discussed that convex will make both real image and virtual image, right? So we have to discuss the fourth case that is related to the virtual image. So point number 4 is we have to place object between. Now we have to place the object between lens and the principal focus. So let's suppose if we place object between F and the principal focus. So this is our principal axis again. And if we consider the lens between it, or we just shift this principal axis slightly lower because we are going to consider a virtual image. So that's why we need more space. So this is our principal axis. This is the position of the lens, right? And if we again mark F and 2F on both sides, taking the same boxes. So 1, 2, 3, 4 again. F, 1, 2, 3, 4, 2F, 1, 2, 3, 4, F, 1, 2, 3, 4, 2F, right? And we have to place our object between F and the lens. So this is our object. And now if we consider the same ray pattern that we already followed, so one light ray will move parallel to the lens, and second will move straight from the center. So the first ray will move from the focus, and the second one will move from the center like this. Now you can see that both light rays are moving in opposite directions, right? They will never intersect each other, right?
Right.
So basically what we have to do, we have to shift these, or we have to trace these lines in backward direction, right?
Right.
Let's
Since it's
suppose,
only virtual image, isn't it?
yes, because virtual image cannot be obtained on the screen, that can be obtained through the lens. So we have to extend these lines in backward direction to get the virtual image. So you can see it will intersect in the backward direction. So you will get your image over here. Okay. So this will be your image. Okay. So basically now you are getting a virtual image, right? Because both object and image are on the same side. And if you want to write the specification for the image, so you may just simply write that the first point is the image is not going to form on the screen, right? So we can say that image will form on same site. It means where object is placed. Next one is virtual image. Third one is it is upright. Okay, because you can see both are in the same position, like arrow is in upward direction. And the final point is it is highly magnified. Okay, clear?
Yes.
So these are four different cases for the image formation that you have to remember, right? And I gave you the concept that if object is going to shift towards the lens, so your image will shift away from the lens, okay? And if your object is shifting away from the lens, so your image will shift towards the lens. So that will help you to identify and to remember these points, okay?
Okay.
Any question, any confusion?
No, sir.